So lesson 15.1, we're exploring interior and exterior angles. So we just visually displayed to ourselves and proved to ourselves in a way that the interior angles of a triangle add up to 180 degrees. So that's pretty cool. So let's continue on. Let's talk about some different ones. So if you go to the next page here, you can see some different polygons, and we're going to talk about them. No. This is kind of, we're continuing on. All right. So triangle. Tri is three. Angles. Three angles. That's pretty cool. Quadrilateral. Quad means four. Lateral. If I'm playing football and I toss the football to the side, what kind of play is that? A lateral. It's got to be to the back, but it can't be past the side, right? So if you're basically tossing it to the side, it's called a lateral. Why? Lateral means side, okay? So quadrilateral means four sides. That's cool, right? All right, so we're talking about polygons here. We know the interior angles of a triangle add up to what, class? 180. But let's now use what we know to discover the measures of the interior angles of other polygons. So before we do that, let's talk about this. If I highlight these points here where the sides meet, what are those called? Vertices. It's a vertex is singular, vertices is plural. Cool. And if I connect one vertex with another, that's called a what? The blue line it begins with a D.
Bisector.
A D.
Diagonal.
It's called a diagonal. Okay, cool. But by drawing that diagonal, class, what did I just create?
Two triangles.
Bam. And what are the measures of the interior angles of those two triangles? 180 degrees. So basically, I have four sides, two triangles. 2 times 180 is 360. So the measure of the interior angles of a quadrilateral is 360. It's the sum of all four angles. Good. Now this next shape here has how many sides? 5. What do you call a polygon with 5 sides? Pentagon. A pentagon. Fun fact: the head of the Department of Defense, the Army, military, all that stuff. It's called the Pentagon. What's the building shaped like? Pentagon. That'd be kind of random. Yes, it's called the Pentagon in the shape of an octagon, and we do that to confuse the enemies. All right. So let's draw the diagonals here and see what we get. So there's one diagonal. Here's another diagonal. And I've created how many triangles? 3. So the interior angles of each triangle add up to 180. So I have 3 triangles. So it's 3 times 180. 5 sides is 3 times 180. Anybody? 540. So the interior angles, the sum of the interior angles of a pentagon is 540. Next one, 6 sides. What's that called? Hexagon. All right. So let's draw the diagonals, and you guys should be drawing with me, whether you have a straight edge or not, it's fine. Just draw with me. Guys, for the record, I do recommend, especially for like this kind of stuff, that you bring your own straight edge or colored pencils and stuff. These books are all black and white. It'd be so much more fun if you had color in them, right? Just saying. Okay, so let's take a look at this. Hexagon, it's got 6 sides, 4 triangles. 4 times 180 is 720. Very good. 720 degrees. So the sum of the interior angles of a hexagon is 720. 7 sides. What's that called? It's not a hexagon. It's a hepta or a septagon. But we'll call it a heptagon. Heptagon. 7 sides. That's fun. So we'll draw the diagonals here as well. And we split it into triangles. I'm not going to put the 180 inside every one. The red dots are the same as 180. I've got 7. How many triangles? I've got 7 sides. I've got 5 triangles. 5. Yes. 5 times 180 is 900 degrees. And then this last one here, 8 sides, is the famous octagon. It's not octagon, it's octagon, for the record. Octagon. Okay, it's got 8 sides. If I draw the diagonals here, so I draw our diagonals here. For the record, there are more diagonals that I could draw, but I'm only drawing these specific diagonals to cut our shape into triangles. 1, 2, 3, 4, 5, 6. 6 triangles means 6 times 180 is how much? 1080. Good job. Good job. 1080 degrees inside of octagon. Sum of interior angles. Okay. Guys, are we noticing a relationship here? Okay, look. If I have 3 sides, I have 1 triangle. 4 sides, 2 triangles. 5, 3, 6, 4. If I have a decagon, how many sides are there in a decagon? 10. How many triangles would there be? 8. I subtract how much? 2 each time. 8 times 180 is...
54 million.
It's a bit high. 1440. 1440. 1440 degrees, sum of the interior angles. So let's recognize something. If my number of sides, I call that n. If n is my number of sides, well then what's my number of triangles? N minus 2, right? And then to get the sum of my interior angles, I do n minus 2 times the number of triangles times 180. So what does this tell us? The sum of the interior angles of a polygon with n sides is equal to n minus 2 times 180. The sum of the interior angles of a polygon with n sides is n minus 2 times 180. Pretty clear? Yeah. All right. So how could this show up? Well, let's write our formula again. Remember, the sum of the interior angles of a polygon with n sides is n minus 2 times 180. And I ask you to find the sum of the interior angles of a dodecagon. How many sides does a dodecagon have? 12. So find the sum of the interior angles of a dodecagon. Dodecagon. gone. Dodecagon.
1,047.
What's the math problem?
So let's take a look. N is 12, so it's 12 minus 2 times 180, which is 10 times 180, which is 1,800. 1,800 degrees. Got it? Any questions? All right, cool. So that's the basic idea. But now let's take a deeper look at this. Shh. Bottom of... Okay, Polygon Angle Sum Theorem. The sum of the measures of the interior angles of a convex polygon with n sides is n minus 2 over times 180. Okay? It's just exactly what I said to you. The Polygon Angle Sum Theorem is exactly what I just said to you. Okay? It's just written there. Now let's take a look.
Sound like a songbird. That's beautiful.
All right. First off, for the nonagon shown, how many sides does the nonagon have? 9. It's got 9 sides. So it says find the unknown angle measure x. Well, all I have to do is find what the sum of the interior angles should be for a nonagon, and then it's all right. Sorry for the people that are below. All right, let's calm it down. Let's calm it down. So we find the sum of the interior angles, and then we add up all these angles plus x, and that should equal the sum. So we find the sum of the interior angles should be n minus 2 is 9 minus 2, which is 7 times 180 is 1260. So all the angles, including x, should add up to 1260. So I add these all up, and then subtract it from 1260, and I get x equals 158. Does that make sense?
Yeah.
Okay, so everyone go ahead and do example B on the top of page 728. Okay, so let's break this down. Determine the unknown interior angle measure of a convex octagon in which the measures of the 7 other angles have a sum of 940. So first we start with the fact that it's an octagon, so n is equal to 8. We find the sum of the measures of the interior angles, so it's 8 minus 2 times 180, or 6 times 180, which is 1080. And then it says the 7 other angles have a sum of 940, so it's just 940 plus x equals 1080. We would then subtract 940 from both sides, and we get x equals 1080 minus 940 is 140 degrees. Does that make sense? You could think about this in a more simple way of just saying, oh, they all have to add up to 1080, so I just do 1080 minus 940, and that's the measure of my final angle. Does that make sense?
Yeah.
So this is just setting up the algebraic equation for it. Any questions on that? Okay, so that's how that would show up. Next, proving the exterior angle theorem. So everybody go ahead and take a look at the top of page 729. Top of page 729. And it says something about an exterior angle. So go ahead and read what it says about an exterior angle. At the top of page 729. Read that to yourself and then we'll go through it. Okay. An exterior angle is an angle formed by one side of a polygon and the extension of an adjacent side. All right, so let's break this down. So we have a polygon, so I'm going to measure a you all right? Thank you, sir. I'm going to create a polygon much like the triangle that you see in the paper below. So I'm going to start with this side. And then it says formed by one side, so I'm going to start by drawing that one side. Okay, pay attention carefully, please. So here's the one side that it refers to. So is an angle formed by one side of a polygon and the extension of an adjacent side. So an adjacent side, what does adjacent mean?
Neighboring.
Neighboring, touching, right, next to, right? So I'm going to draw the adjacent side now. The adjacent side is right here. But it doesn't say that the angle formed by one side and the adjacent side, it's the what of the adjacent side?
Outside
The extension of the adjacent side. So here in green is the extension. So let's take a look carefully. The exterior angle is an angle formed by the one side and the extension, so that's this right here. So you see how that's the exterior angle? Does that make sense? And exterior obviously means outside. Okay? So that's an exterior angle. So let's now take a look. So we'll keep that up here. Let's now take a look at this. It says proving the exterior angle theorem. So let's go ahead and do that. Let's venture into this territory. Okay. So we have angles. Pay close attention. We have angles 1, 2, 3, and 4. Raise your hand if you think angle 1 is the exterior angle. Raise your hand if you think angle 2. Angle 3? What about angle 4? Yes, nice. Okay, so angle 4 is the exterior angle. What do we know about angle 3 and angle 4? They form a what?
180 degrees.
What are they called? A linear pair. And by the linear pair theorem, we know that a linear pair of angles is supplementary, and supplementary angles by the definition of supplementary add up to 180. So we know, therefore, that the measure of angle 3 plus the measure of angle 4 equals 180 degrees. Very good. Now I'm going to highlight angle 1 and angle 2, and I'm going to call these remote interior angles. Not just interior angles, but remote interior. What are they remote of or removed from? They are removed from the exterior angle, right? So here's the interior angle that's adjacent to or forms a linear pair with the exterior angle. But these are remote interior angles because they're away from it. Does that make sense? Those are the remote interior angles. So what do I know about those two remote interior angles in angle 3 or 1, 2, and 3? What do I know about them?
They add to 180.
They add up to 180 as well. So another statement that I can make here is the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals what, class? Equals 180. Equals 180. Good. So if I know that those, now 3 plus 4 is 180 and 1 plus 2 plus 3 is 180, so they both are equal to the same thing, which means they're both equal to each other. They're both equal to each other. So by the what? Transitive property of equality. So, transitive property of equality says if two things are equal to the same thing, then they are equal to each other. So M3 plus M4 equals the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. Does that make sense? They're equal to each other. What do I notice is on both sides of this equation? Measure of angle 3. What can I do with that? I can cancel that. So I subtract the measure of angle 3 from both sides. And what do I get? The measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. What? What did I just show? That this exterior angle is equal to the sum of the remote interior angles. Whoa, that's deep. Guys, what did we just do? If we were to create a technical name for the process that we just went through, we would call it a
postulate, a theorem.
What did we just do? We just did a proof. So we just did a proof, you see? Okay, so we proved something through this process, so very good. So we proved that an exterior angle is equal to the sum of the remote interior angles. Okay, so what does this mean in very simple terms? If I told you that this angle here was 30, or rather it looks more like 70 degrees, and this angle here was 60 degrees. If this was 60 and that was 70, what would this one be?
130.
130. You see? Does that make sense? Okay, the exterior angle is equal to the sum of the remote interior angles. Now, obviously, that would be a very simple example of a question that I could give you. But what would be a more likely question? Well, let's take a look just down a little bit in your book. If you turn to the next page, you see example A. Got example A and example B. So example A says find the measure of angle B. So the measure of angle B, notice this is a remote interior angle, this is a remote interior angle, and this is the exterior angle. So how do we find the measure of angle B? We set the sum of the two remote interior angles equal to the exterior. So we get 2z plus 5z minus 2 equals 145. Or in other words, 7z minus 2 equals 145. Add 2 to both sides. 7z equals 147. Divide both sides by 7. And I get z equals 21. Now, that's not exactly what it asked for. It said find the measure of angle B. So I plug it in. 5 times 21 minus 2 is 105 minus 2 is 103 degrees, which is your final answer. Does that make sense? Okay. So that's good. Now go ahead and do example B on your own, please. Read the question over. Solve. Okay. Here's my exterior angle. Here are my two remote interior angles. First off, what's the measure of this angle here? 90 degrees. So I add the two remote interiors. 90 plus x plus 2 equals 3x minus 8. Combine like terms, x plus 92 equals 3x minus 8. Add 8 to both sides. X plus 100 equals 3x. Subtract x from both sides. I get 100 equals 2x. Divide both sides by 2. X equals 50. But this is where you have to be careful. Did it ask me to solve for x? No, it asked me to solve for PRS, which is which angle? The exterior angle. So I plug x in there. I get 3 times 50 minus 8 is equal to 150 minus 8, which is equal to 142. That's my final answer right there. $142. Any questions about that? Okay. Good. That's it. Praise God. So listen, homework leads us to a homework. Your homework is on page 232, numbers 3 through 16. Pay attention to this last point. Number 16. Take a look. Number 16 says solve for this one angle. If you go ahead and solve for the other angles as well, you will get extra credit. But you have to get the right answer. So if you solve for all the angles, you get extra credit, but you have to get the right answer. That's for number 16.
What did you say the whole homework was?
732, numbers 3 through 16. Homework, page 732, numbers 3 through 16. And remember, if you find all the angles in number 16, you get some extra credit. Hold on one second. Okay, any questions?